All right. Morning, folks. Afternoon, evening, whatever time period you call this. It's the morning in California. Got at least one thing right today. Okay. So yesterday we talked about differential equations. That's what we were leading into. It was the whole idea that we need to separate variables and that we're only going to look at this one type. We led off yesterday talking about separation of variables, how that's really important. So important that they've made the decision that when you do a separation of variables problem, if you don't show that step on your paper at the very beginning, you get nothing. I don't care if the rest of the problem is right, you get nothing. Which is not cool, and we don't want to wind up like that. So we got this separable variable issue that we talked about. After we've dealt with that, we started looking. We realized some of these got really wacky. Just to give you a heads up, like 15 and 13, I've seen questions like that before. I've not necessarily seen a question like number 12. But of course, if I haven't seen that, that means that, hey, this year may be the year. So one thing that I've learned from AP testing in general, whatever you think you expect, just stop expecting things and you'll be fine. Just teach the material and hope for the best at that point, because they'll ask something weird. That's part of the AP test, is not only do I have to teach you how to do the math, but also leave you with hard enough and interesting enough questions that when you see a weird thing, you're able to accommodate. So then we went through the process. We talked about how to take the antiderivative after we separate, which was nothing new. We talked about the general solution. We talked about coming up with a particular solution. We talked about particular solutions. We discussed making sure that your ranges and domains matched with the original question. We then went through and we talked about how being careful that since this had a y to the 1/2 and it's positive, when we did the square root up here, we actually, because it was y to the positive 1/2 already, we didn't have to consider the negative concept. So again, thinking about the range. And then we ended off with the occasional problem where we have to understand that sometimes the answer we get may look different than somebody else's answer and still be absolutely correct. And that was frustrating, because suddenly math is no longer this wonderful black and white. I got 3, you got 3, you got 4. So one of the two groups is right, hopefully, and one of the two groups is wrong. Now we start getting solutions where we have to go, okay, I got something slightly different than yours, but it looks mainly the same. Let's see if we can play with the signs to make it match. Oh boy, that'll be fun. My opinion, this is when math actually starts becoming real math. When you start getting situations where your method of solving is unique to yourself, your answer can turn out to be slightly different form. And I will tell you that even though this feels like it's gray space in math, this would still be a very black and white solution. Because the fact is, we both... Did anybody take stats before? Does anybody... It took 3 weeks. That does not count. Took 3 weeks of it. I have experience. Yeah, you didn't even get to the fun stuff where you could get one answer, someone could get a different answer. You could both explain your answers perfectly, and both of you get a perfect score on the AP Stats test. Because you both did a good job defending your hypothesis test. It's good times. So, before you all think that it's, there is a little bit of art to that, but it is, it's good stuff. Okay, what I'd like to do is I would like to show you one antiderivative, one particular question that has a natural log as we go through. So if you'll all flip to the 2008 question. I believe it's 2004, it's 2004-1, 2008. So it's 2008, number 5. dy dx is y minus 1 over x squared, where x is not equal to 0. We're going to find a particular solution. I just want to work through this because I want to show you what happens. You're going to get to deal with a lot of problems that look like this, but I want to make sure that we kind of have a chance to play with it a couple times before I set you loose and say, hey, go figure it out, have fun. All right. All this question is right now, here's your dy dx. X is definitely not 0. Okay. Our job is to find a particular solution y equals f of x, given that f of 2 is 0. What's the first step? The y's on one side, get the x's on the other, separate those variables. We call this what? Oh, yeah, it's okay. What's the actual thing once we separate the variables? dy. That's fine. You can call it dx, x to the negative 2 dx would be perfectly fine. I would not call that y minus 1 to the negative 1 because that's to the negative first power. And we know that if we try to do a power rule on a negative first power, that doesn't work. So I will use on negative exponents greater outside of 1. I'll use that. But if it's a problem like dy over y minus 1, I'll leave it like this. And we'll see why in just a minute. So your job is to take antiderivatives. The right side is probably the easier of the two, so what is the antiderivative of the right side? What'd you say, Trin? Close. Should be negative x to the negative 1. Because that's technically x to the negative 2 plus c. What about the left side? I realize it looks like it's dy over, but that's technically 1 times dy, so that's 1 over y minus 1. By the way, what technique did we technically use to get that solution? That is a u sub. Now it's a u sub that doesn't do anything special because y minus 1 you get dy as du, but there's nothing interesting that happens there. Okay? I'm going to rewrite the left side. I'm going to call this natural log. The absolute value of y minus 1 is negative 1 over x plus c. I got to get the y by itself. No, y. What do you do? Yeah, I'd say e to the natural log of y minus 1 is just y minus 1, and this becomes e to the negative 1 over x plus c. Now, I don't like e to the negative 1 over x plus c. I'm going to call it e to the, not plus, equals e to the negative 1 over x times e to the c. Can turn that into a multiple. But I'm actually going to take it one step further, because there's a really cool thing I can do. What is e? What type of a number is e? It's a constant. What type of a number is c? What's a constant raised to a constant? So do you agree that this is really e to the negative 1 over x times a constant? Yeah. Let's call it that. No, I just stand on the shoulders of giants. So we simplify this to y equals ce to the negative 1 over x plus 1. Cool. Out of 5 points, you've earned 3. we need to substitute in the initial conditions. So when x is 2, y is 0. So 0 equals c e to the negative 1 over 2 plus 1. Agreed with that? So let's rewrite that. I'm going to call that negative 1 is equal to c over e to the 1/2. Therefore, c must equal negative e to the 1/2. Cool. So what is y? Negative e to the 1/2 e to the negative 1 over x plus 1. Or if you simplify that down a little bit, you can call that negative e to the 1/2 minus 1 over x plus 1. Either of those will work. The trick there is to get used to the e thing, and the big thing that I really wanted you to notice is when I have that e to a function plus c, I can rewrite that as a constant times e to the function. So it's really getting the c out of this spot and into that position right there. Which leads to the question that I'm really interested in going over. The next one. It's a question about the weight of birds. We've got a baby bird. It gains weight. Apparently its weight gain is proportional to the difference between its adult weight and its current weight. At times t equals 0, when the bird is first weighed, it weighs 20 grams. If b of t is the weight of the bird in grams at time t days after its first weight, then db dt is 1/5 times 100 minus b. Let y be b of t. Be the solution to the differential equation above with the initial condition b of 0 is 20. Take a look at part A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. I'm going to give you all some time to think about this. I'm going to also put a short pause in the video because there's no point while you're thinking of running a video. So the purpose of this question is to get you to look at and realize, what am I asking you to do? If I'm asking you, is the bird's weight gain faster, what am I asking you? When is the rate that the bird is gaining weight larger? If b of t is the weight, then db dt is the rate at which you're gaining weight, right? So essentially what you needed to prove was, hey, look, when dB dt is being evaluated at 40, that would be 1/5 of 100 minus 40, which is 60 over 5 when B is 40 grams. And if we look at dB dt, remember I keep saying prove it. This is how you prove it, folks. 30 over 5 and what do you notice? Of course, when the B is 40, dV dt is greater, so we have the faster weight gain. At B equals 40 grams. And I've proven that because you can see analytically right there, it's been proven. Okay, so that wasn't terrible. Could have been a whole lot worse, right? Read through part B. Let's deal with part 1 of part B. Find the d2b over dt squared in terms of, what on earth is that? What is that asking me to do? Simply take the derivative of the b of t. So I need to come up with what on earth does the second derivative equal? So, taking the derivative. Not bad. You can do that. It is. I'm not going to spend a lot of time waiting on this, so I don't need to really pause. Hello. I should. Yep. Yep, I've got a whole bunch of them. Yep. There we go. We got Abel. We've got, whoops, sorry. We've got Andy. Thank you, ma'am. We've got Jake. And we've got Nina. My favorite part of that is this has nothing to do with working at McDonald's. I don't know. That's what it says on the bottom of the paper. All right, so what is the derivative? You should have that done. Negative 1/5 dB dt. Now, I'm going to tell you that that's not going to earn you points yet, and I'll talk about that in just a second. But how on earth did I get negative 1/5 dB dt? If I'm taking the second derivative of dB dt up here, that's 1/5 times 100 minus b. I don't really want to have to use product rule, so I'm going to go ahead and distribute the 1/5. Take a derivative of a constant, that's 0. Take a derivative of negative 1/5 b. And the derivative of b with respect to t is dB dt. Now, this isn't a correct answer because I don't want this to be in terms of dB dt. I want this to be in terms of b. So how am I going to fix that? I'm just going to take dB dt and rewrite it. So negative 1/5 times 1/5 100 minus b to give myself negative 1/25 100 minus b. I took dB dt and just subbed it back in. And then the next part of part B here, use the second derivative to explain why the graph of B cannot resemble the following graph. So, what I am telling you is that if you use the second derivative, you should be able to easily come up with a reason why that graph is wrong. Again, I'll let it pause for for about a minute or so to make sure that you get a chance to think about that. So when I'm looking at a second derivative tells me what about the function? Concavity, right? So what does B represent? B is your weights, right? Yes. Take a look at this graph. What weights am I looking between? 20 and 100. But wait, if I pick a number between 20 and 100, that means this 100 minus B will always be positive times the negative, which means the second derivative is always, which means the function should always be, ladies and gentlemen, there you go. I would say something like this. On B from 20 to 100, the second derivative of B is going to be negative. So, B of t should be concave down. And I'm going to put that, I'm going to restate on that B from 20 to 100 just to be safe. And say, hey, look, I'm taking that into account. I really want to make sure that they understand I am only looking between 20 and 100 for my weight. So this graph should actually look something like that, not the other way around. Which, again, explains why at 40 it should be growing faster than at 70, right? Yeah, so once we get into this piece, yeah, sure, that works, but it doesn't curve up like that. We will look at functions where that is actually a situation, but that's not this particular problem. The negative 1 over 25? Certainly. When I took the derivative of B, dB dt, I rewrote this as 100 over 5. I'm lazy. It's a constant. It's 20, but whatever. 1/5 b, right? So you take the derivative of the constant, that's gone. That becomes negative 1/5. The derivative of b is 1 dB dt. So now I've got the negative 1/5. But dB dt is already 1/5 times 100 minus b. So I just went ahead and I replaced the dB dt with a 1/5 100 minus b. 1/5 times negative 1/5, negative 1/25. All right, last question. Use separation of variables to find y is equal to b sub t, the particular solution to the differential equation with initial condition b of 0 equals 20. Here it is. Here's the 5 to 6 point question. Initial condition. We got an initial condition. We need separation of variables, so let's start with that. Let's separate the variables. What would this be if the variables are separated? Equals 1/5 dt. Last period someone asked me, could we move the 1/5 with the problem? Certainly. The problem with I would personally have with that is that eventually you're going to have to move the 1/5 back over anyways. You might as well leave it on the right side because you're going to put it back on the right side eventually. Now you can't do that with the 100 obviously, that's got to go with it. By the way, you remember that lovely question I keep talking about with the baked potato? This was almost the same exact style question, and people missed it. Because there was no t in the problem, and they said, well, how do I separate the variables? I only have a b, I don't have a t. That's okay. You're going to find out that in a lot of situations, the weight of a bird, as the bird starts to get heavier, the weight of the bird the weight gain of the bird starts to slow down. That's nature. That's how things work. So sometimes a function depends on itself. Population is a perfect example of that. If there's only 5 people in the population, does population increase really fast? No. A couple 100 million of people, does population increase faster? Certainly. The population depends on the previous population. Okay, so dB dt, we did that. Congratulations, you got a point here. You need to take the antiderivative. I'll deal with the right side, 1/5 t plus c. I know. What about the left side? Not right. It is not the natural log of 100 minus b, although you are ridiculously close. Oh, he said the absolute value. Why? How do you do that problem? What technique do you use? You have to u sub, and because it's a negative b, du is going to be a negative dB. So you have to watch out for that u substitution on those problems, especially on questions like this. Do not just assume, well, the last 15 ln's we've done, we haven't had to u sub it, or we've u subbed it and nothing's happened, so clearly every time we u sub it, nothing will happen. There's nothing further from the truth there. So I take this, we get ln of 100 minus b, negative natural log of the absolute value of 100 minus b equals 1/5 t plus c. Let's get rid of the negative, so the natural log of 100 minus b, absolute value of 100 minus b, is the negative 1/5 t plus c. Remember, we're not going to worry about changing that into a negative. We'll do the e thing. 100 minus b is equal to e to the negative 1 over 5t plus c, and we don't like that, so how do I rewrite this? C e to the negative 1/5 t. Makes our life a whole lot, and I skipped a step there. If you need to see that step where it's e to the negative 1/5 t plus, times e to the c, and then write that, fine, do what you need to do. We do some manipulation. B is going to be 100 minus the CE to the negative 1/5 t. Now that we've gotten there, what can we do? Substitute in initial conditions. We said B of 0 equals 20. So we've got 20 is equal to 100 minus CE to the negative 1/5 times 0 is 0. e to the 0 is 1. So 20 equals 100 minus c. C must equal 80. Therefore, b of t must be 100 minus 80 e to the negative 1 over 5 t. That's a lot. It is a bunch of work. I will tell you that that was also an entire free response question. No, that was part A, B, and C there. That is 9 points of work we just showed. Okay, that's almost 10% of the test right there. So that's a lot. I realize that, but that is the expectation. So that's why we got to make sure that we know what we're doing on those. Ladies and gentlemen, what you have are many, 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 many other free response questions before this one. You'll notice we're not doing the Euler yet. That is coming up tomorrow, so do not move over to the Euler method questions. You will notice that every single one of these, 2000, number 6, 2000, number 4, 2011, number 6, 2011, AB 5, all of these questions are from AB tests, so if you want to look up answers to these, they are available, readily available online. All you have to do is type in 2011 AB 5, and the scoring guideline will show up. Okay? I'm going to let you have time to work on these in groups, work on these with each other, by yourself, however you prefer to do that. But go ahead and start knocking out some of these questions. And yeah, I'll take questions on those tomorrow and show you some other methods to dealing with differential equations.